another task we may be called upon to do in the machine shop, and that is boring a hole. We can drill and ream holes, but only to a certain size, and then boring becomes a much more practical approach for a given hole diameter. Old farmer down the street had brought in a sample part for us, and he needs this hole picked up and bored to a larger diameter. It's probably about, an inch diameter right now, and he wants to open it up to 1.25 inches. We don't have 1.25 inch drill. It needs to be a precise fit to mate with this hole pattern that he has. I guess it bolts up on the side of his diesel motor on the tractor. It's some type of a flange adapter that he has. So in order to do this, we're going to need to come in and dial indicate the hole. But before we do that, let's take a look at a Criterion boring bar that we will be using in the boring process. This particular boring head is made by the folks at Criterion in Costa Mesa, California. Probably one of the finest boring heads that you can buy. Again, they come in different sizes. This one has an R8 stub arbor on it, so it's going to replace the contour of an R8 collet. This is a model DBL 202. The DBL stands for double hole, so you can see if we're going to be boring a larger hole, we would simply offset our cutter, and that increases the range at which we can bore. The boring tool works basically on a large dovetailed assembly. We've got a dial here that's graduated in thousandths of an inch on the diameter that we're dealing with. Okay, it's very important you keep that in mind, that this is working off of the diameter. The 3 set screws that you see on the side are simply gib block screws, if you will, very similar to what we have on the mill. We snug the outer 2, we leave those alone, and then we loosen and tighten the center one in order to make our adjustment. So we'd simply loosen that, go to our dial, and then increase or decrease the number of thousandths of inch that we want to do our hole. Now if we look on the side, you can see how the dovetail itself is becoming exposed. There's a little screw in the side that we look in the back here, and that's also a guide as to the amount of offset that we can have in this particular boring head before we need to switch to the second hole in the bottom. So we'll go ahead and advance the boring head out quickly and show you its maximum range with the center offset. Okay, when you see the screw become flush with the outside of the boring head body, that's about the maximum application. All right, stop at that point, use a larger boring tool, or simply offset to the next hole in the bottom, and this will increase our bore diameter. Now let's take a minute and talk about the boring cutter itself that goes in the boring head. This particular cutter is a carbide inserted cutter, very similar to what we would use in the lathe if we were boring as well. You can see the carbide insert on the end. It's got a 1/2 inch diameter shank that goes into our boring head. You can get these in different lengths. Again, like an end mill, like a collet, we want to keep as rigid a setup as we can. If we're only boring a 1/2 inch or an inch thick piece of material, the boring bar itself should only protrude maybe an inch, 1.25 inches. Okay, again, this gives us maximum rigidity, which is also going to provide accuracy in the bored hole. If we have a real long boring tool, it's going to have a tendency to flex on us, so we're going to want to continue when we get close to our finished diameter to continue making passes, eliminating the spring or flex out of the boring tool, and then measure for final size and make the necessary adjustments from there. All right, we'll go ahead and retract the boring head. We're going to locate the hole now. Remember the tip that we showed you earlier about taking an end mill or something in the drill chuck or collet and using it as a quick guide to get to the center of our hole, and then we can fine tune it with the dial indicator. So we're simply going to install it, eyeball that into place. Okay, that looks pretty close by eye. Let's go ahead and put the coax indicator in and see how close we got it. Okay, we're going to go ahead and preload our dial, bring it down to about the center of our hole in terms of width. Okay, we'll shift our machine into back gear. Okay, make sure when we're using the coax indicator that we hold on to the little stem here. We can mount something on the table as a little back bar, but we don't want to allow this to be swinging around. We can damage our coax indicator. So I like to just hold on to it while I make my adjustments. Okay, we got her pretty close, within about 15 thousandths. So we're going to turn the y-axis. Come over to the x-axis now. Okay, now we're starting to fine-tune the hole. Okay, there we go. We've got that hole indicated within about 1/10. Shut the machine off, lock our gibs down. Got a positive location on that hole. We don't want anything to shift or change. And let's remove our coax indicator. For those of you that have dialed in a lot of holes the old-fashioned way, before the brains at Blake Manufacturing came up with a coax indicator, you can see what an invaluable tool this is, and a time-saving tool as well. If we've got a lot of holes to do, this is going to save us a lot of time, giving us more time to spend that money we're making. Okay, install the boring head into the spindle, apply the brake, tighten it up. We're going to go ahead and lower the quill down, and we can see that we need to offset the cutter more in order to get the diameter that we desire. Okay, lower the boring tool down, and then we're going to start advancing the cutting edge towards the edge of our hole. Okay, now we've got quite a ways to bore, so we're just going to come up and kiss or come in contact with the edge of the hole, remove our Allen wrench that we made the adjustment with, and then tighten down the center screw. Okay, so now we're at a fixed position. Let's go ahead and see what kind of contact we have and clean up that hole. All right, so we're going to turn this at about 1115 RPM, or second gear in the direct drive. Okay, we're just a little bit under. We'll go ahead and loosen again and advance our tool out. Let's go another 20 thou. There we go. Now we're just starting to cut. We're manually pulling the quill down in that boring operation. Now you're going to see, because of the offset, that we've got kind of a counterbalance problem occurring here. So we don't want to really turn it up fast and accentuate that counterbalance. Around 1100 RPM, depending upon the diameter of holes that we're boring, is about right. Now remember earlier when we were going over describing different parts of the mill, we have a power feed application on our milling machine. Let's go ahead and put that into use and save the wear and tear on the right arm of pulling that quill down. We're going to take another 20 thousandths pass. I like bringing the cutter down in contact of the work, retracting it 30-40 thousandths before we start the machine up. Now let's move to the top of the mill head and make the necessary adjustments to engage the power feed. All right, this is our power drive on the spindle. We need to engage that gear. Okay, you'll have a little sign usually above them that says in and out. We want to engage that gear. We're now ready to turn the machine on. Do not make this adjustment while the machine is running. Always turn the machine off before engaging that gear. Go ahead and turn the machine on. We're going to come over and establish our drive direction by retracting or pushing in our gear here. We've got our feed set at 3 thousandths per revolution. Now let's engage our clutch and go ahead and bore through that hole on power feed. Once you clear, simply disengage the clutch, manually retract it. We're ready to make another adjustment on the boring head, again increasing the diameter of the hole. Depending upon the material that you're doing, we can take a pretty heavy cut. Let's go ahead and make this next cut a little bit heavier, about 80 thousandths. Okay, you can see we're removing quite a bit more material at that point. Now, when we get close to our finished diameter, you can see we've made a pass. We've got quite a bit of protrusion of the boring bar itself in the boring head, so we're getting a little bit of flex. So let's go ahead and retract the head, engage the power feed again, and watch it take off those microscopic shavings from the flexation that we had. Okay? Once we've got that to final size, we can go ahead and shut the machine off. Retract our cutter. Now we can take an accurate measurement of our hole to determine how many more thousandths that we want to take. We can also vary the rotation or the amount of feed that we have in the power feed. 3 thousandths is usually about right when we're dealing with aluminum. Each application is going to vary though. If we're machining hardened steel, go to the 1.5 thousandths per revolution feed. If we're going through some plastic or material that we can really pour the coal to it, go ahead and make your adjustment up to 6 thousandths. All right, let's take a measurement of the hole, see where we're at. Go ahead and use our dial calipers for this. Okay, we're at 1 inch, 229 to 30 thousandths in hole diameter. So we're going to go ahead and sneak up on it. Let's take another 15 at a pass, and that'll take us around 245, and we can make our final adjustments from there. Let's give you a close-up view of our adjustment now. You can see the little dial on the inside of the boring head. Simply insert our Allen wrench. There's 5 thousandths, 10 thousandths, 15 thousandths. We're going to go ahead and lock it down. You're boring a real precise hole. I'll go through it 2 or 3 times to where I don't have any cutting action taking place. Allowing the cutter to spring back into a natural or relaxed mode, if you will. We're just shaving off 10 thousandths of an inch at that time. Okay, let's stop the machine, make sure our hole is clean, take another measurement. Okay, we've got around 246 thousandths. Let's take another 4, and that should pretty well bring our part into specification for the farmer down the road. Give it a little shot of WD-40. Okay, let's check our hole and see if it's the final dimension. Okay, there we go, 1 inch 250, right on the money. Now, let's go up and work to the top of the mill again and practice the auto disengage mode, if you will, working against the quill stop. We can take our tool. We know what depth that we want to bore to, or just through the hole. We're going to go ahead and bring our quill stop in, lock it in place with the lock ring, retract our tool. Let's go ahead and bore down and watch it disengage at that point. This is really handy if we need to bore to a specific depth. Okay, as soon as we come down and bottom, automatically disengage. Okay, we can retract our tool. For boring a relief in something or counter boring a specific hole, this is a really good method to use in order to do it accurately. As that quill comes down, bottom's there, it's going to disengage our feed, and we can retract the tool and we're ready to go.